Question 2. Two equal positive point charges, 2 microcoulomb allocated at x equal to 0, y equal to 0.3 meter, and x equal to 0, y equal to negative 3 meter respectively. So what are the magnitude and direction of the total electric force that these charges exert on a third point charge at x equal to 0.4, y equal to 0. So this is giving us a coordinate. So basically we have to draw the diagram based on the coordinates given na. Okay, so we have this, and then there is a charge somewhere at x equal to 0, y equal to 0.3. Okay, and then this po na sa 2, and then the tsaka 0.4, that is just assume it's here lah. Okay, so this is the third point charge, and then this one is Q1, this is Q2. Okay, so this is Q3 lah. Okay, and then the distance is 0.4 here, and then this one here is 0.3 lah, similar to this one. Okay, so this is 0.4 meter, 0.3 meter, 0.3 meter. Okay, so that is the diagram. Now we are gonna draw the force vector diagram. So that is gonna be only looking at the charge number 3. Okay, so this is Q3. Okay, this is charge 3. So we are gonna look at what are these force gonna be. I mean the direction of the force for Q1 and Q3 dulu. Oh no, kita Q1 and Q3 lah dulu. Okay, so for charge 1 it is a positive value, so this is a positive charge, and then this one is also a positive charge, and then this one is also a positive charge. Okay, so since these are positive charge, they all gonna be the forces are gonna be away from each of the charges lah, because they are experiencing what we call a repulsive force. Okay, so instead of them going like this, they will try to get away from each other. Okay, so the direction of the force due to charge 1 will be here. Okay, and then for charge 3 and 2, this is positive and positive as well, so this will be pointing out of each other again. So this is gonna be here. Okay, wait, sini balalannya. Okay, so this is, let's label them first. Sorry if the music is too loud. This is force by charge 1 on charge 3. Kan? Okay, and then force by charge 2 on 3. Okay? And then what else? Yeah, that is basically the diagram lah untuk the direction of the force vector. Okay, but we need to consider the distance because we will be using the distance punya value, so we have to find lah this distance here. Okay, so if the distance if we find the distance here, alamak, we should get the distance from 2 and 3 is also the same lah. I don't need to draw that. Okay, not D, I'm just gonna label it as R lah. Okay, so how do we find that distance is we can actually use what do we have? We have opposite and adjacent, so that is A, so we can use tangent. Okay, so that is your theta. Okay, so basically you'll have wait, Okay, so that is for the tangent theta. So we'll get TOA or op 0.3, 0.4. So the angle is gonna be equal to 36.9 degree. Okay, so that is the angle needed when you are gonna resolve these force vectors lah. Okay. And then what else do you need? Okay, so basically we can actually calculate R by using Pythagoras theorem, but if you remember, the combination is 3, 4, and 5. Remember? So basically you'll have R equal to 0.5 meter. Okay, so if you are unable to calculate this 0.5, you can just use Pythagoras theorem lah. Okay, kalau kamu hafal, it is 3, 4, 5. Okay, now we can calculate the force on 1, 3 to be equal to K Q1 Q3 over R square. So you'll get 0.288 Newton, and then force 2, 3, do the same thing, just change the charge, and you get 0.288 Newton as well. Okay, why is it the same? Is this because the distance is the same, the value of the charge is also the same? Okay. Sorry, this should be 2. Okay, all right, so since you have the values already, now if this is only on the x-axis, the forces are on the x-axis, then we don't need to resolve them. But since they are there is 2 components acting for this electrostatic force, we have to resolve them in x and y component lah. Okay, so for x component, we have F13. So let's look at F13. We have to resolve it into here. So we've calculated the angle just now. It should be 36.9 juga di sini lah. Okay, boleh lah. 36.9 ni equal lah sini. Theta is here, so this is equal. Okay, don't get confused. Let me just label it lah. Okay, same thing goes to this part lah. Okay, sebab we've calculated this earlier. Okay, I'm just gonna label this as theta as well. Okay, so we have to resolve them into, okay, let's resolve them into the x and y component. So F13 in the x component is cos theta, and then for the y component you have F13 sine theta, and then for the F23 pula, it is cos theta as well. Make sure you are able to resolve. This is from our last semester, sorry. Okay, so this you have these values, add them together, you'll get a total here which is equal to 0.46. Same thing here, and then you'll get 0 here. Okay, so the magnitude of the force is fx square plus fy square lah. Okay, so you should get the value 0.46 Newton with the direction to the right lah. Okay, so the direction is to the right. Yeah, so that is your solution for question number 2.